Hello everyone watching this video. Today in this video we will discuss the graphs from 1D motion or one-dimensional motion for NEET and IIT JEE. So in the one-dimensional motion we discuss about the displacement, time, velocity and acceleration, and we derive the relation between these things, between displacement time, between velocity and time, between acceleration and time. So there are some graphs which are important. Sometimes in the examination you get the graphs, and sometimes you get the graphs in the option and you are asked which is correct, and sometimes you get the equation in the option but equation in the answer, but in the option you get the graph. So for that I will discuss the graphs for NEET and IIT JEE. It is very important, please go through it, and if you need you can make the notes. So here we start from first case. So in this segment for the graphs we have three types of graph. First is displacement time graph, second is velocity time graph, and third is acceleration time graph. So here we come, if an object is moving is not moving, then its displacement is 0, or we can write is small s also, displacement is 0. Or if its initial point is here and if its displacement is here, small x or x naught, and after some time it reach here and it's not moving from this position and we start counting time from here, then the graph for this object will be a straight line parallel to the time axis, or this value is x naught. This value is x naught. So here we start counting the time from here, and after that if this object is not moving, then this displacement is constant, which is equal to initial displacement x naught. So when we start counting the time is moving continuously but object is not. So with the time the displacement of the object is remain constant or remain a fixed value. So here we are moving but displacement is not moving, or value of displacement is not changing. So this is the graph for displacement constant. If the displacement is constant, then graph is a straight line along the time axis or parallel to the time axis, and here this value is the initial displacement. So this is our first case, but you don't get all the time this type of equation. This is for rest state, but this object is moving continuously or in the motion, then this displacement is changes continuously, and graph for this displacement will here you can see along this line. This is the initial displacement, which x naught. Or if this object start from initial point where x is 0, there is no displacement before we counting the time, then this graph will also start from this initial point, which is here. This is not a curve, this is a straight line. So this is a straight line curve, because you know s equals to displacement equals to velocity into time. Displacement equals to velocity into time. Here if the velocity is constant, then time and displacement has the equal relation or proportional relation. Displacement equals to time. So for the proportionality sign we use the straight line graph. So this is very quite simpler things, but the next case, the velocity time curve, which is very complex and which is very important. This is the important case and point of view of NEET and IIT JEE that we are going to discuss. So here in the velocity time case we also take three cases. In first case if the velocity is constant. So this is the object. Suppose this is the object, its initial velocity is u and it start moving and its velocity is not changing. So at any instant or at any time its velocity remain constant, which is u. So when we start counting the time from t equals to 0, when we move ahead, time will move and time will become have some value, but value of the velocity remain constant. For this case, in this case, if the velocity is constant with respect to time, then the graph will comes parallel to the time axis, and this value is u, or this value is belong to the initial velocity. So with the time, this graph represent that time is changing, or value of time or measurement of time is changing, but the speed or velocity of the object is not changing. It's constant at u, and with the time it's stay at u only. So this is for constant velocity, but we don't have this case always. If we start from 0 with initial velocity and if we reach at final velocity v, then we have the case of changing velocity. So here we have the acceleration. Here we have the acceleration which is 0. There is no change in the velocity with respect to time, then acceleration is 0. But here we have the change in velocity with respect to time, then we have a acceleration here. And there are two cases for changing velocity. In first case, we have the acceleration, a constant acceleration, and in second case we have the variable acceleration. So first case is here, in which we have initial velocity u, so we write here, and final velocity is v, is the velocity axis, is the time axis, and to reach from u to v we take the time from 0 to t. So here this is the final initial velocity, and this is the final velocity after time t. So this is the initial position, this is the final position. So our acceleration or change in velocity is constant. So we can write, this is the formula, v equals to u plus at. So this is the constant value, and this is also constant because it's initial velocity. So this is graph look like equals to y equals to c plus mx, or I can rewrite it as y equals to mx plus c. So this is the graph for straight line in which y is the perpendicular axis, x is the horizontal axis, and m is the slope here, and c is the constant. So this equation is look like same is this equation of coordinate. According to that, v equals to u plus at. U is the constant, a is the slope, and t is the time. So acceleration is the constant, so slope is here. So this is the graph for changing velocity with constant rate. So at any time you can see the slope is fixed. If theta is here, theta is also here, slope is constant, and acceleration is constant. So acceleration which is a equals to dv by dt. So this is also show the slope. So here the slope is constant, so we can say acceleration is constant, and you don't need to think much. You can direct memorize that for the constant acceleration, the velocity time graph become a straight line. And for a acceleration 0, velocity time graph along the or parallel to the time axis. So there are two axes. So this is the first case, this is the second case for acceleration, and the third case in which we have the acceleration and changing acceleration. Before that, we discuss one more case. Sometimes we see graph like this. This is the initial velocity, this is the final velocity is the velocity curve, this is the time curve. Sometimes we get the curve in this manner or in this manner. This is showing that initial velocity is more and final velocity is less. That means this curve is a straight line. So here one thing is clear, that oscillation is constant but velocity is decreasing, so oscillation is in the negative, or we can say this is not oscillation, this is the deceleration. This is the deceleration, or we can say oscillation in the opposite direction. So this graph, you don't need to be panic or don't need to be worried about this. When you get this, there is a simple thing that oscillation in the negative or velocity is decreasing. So here we have taken the two cases, and next we take the third case in which we have the variable acceleration and variable velocity both. So here we have the axis, this is the time axis, this is the velocity axis. Initial velocity is u and the velocity is increasing from u to v, and here an oscillation, and oscillation is also increasing. Oscillation is also increasing. So we draw the graph here. So initial velocity is u, final velocity is v, and there is one more graph that we get, and this graph in this manner. The final velocity is v, initial velocity u, this is the time t, this is the time t. So for the variable oscillation velocity time graphs, there are two graphs. One have this type of slope and second have this type of slope. So in both of the cases, oscillation is changing. Oscillation is changing, but how the oscillation is changing, we will find out by the slope. I have told you that if you have a constant slope, then oscillation is constant. Here the theta, here the theta. So in case the oscillation is constant, but here you can say this is the angle theta 1, this is the angle theta 2. So theta 2 is greater than theta 1. So see here angle or slope is increasing, so oscillation is also increasing because oscillation relates to the slope. Slope means tan theta. So if theta is increasing, tan theta is increasing, slope is increasing, and oscillation is increasing. And in this case, you can see this is the theta, in this case theta 2, theta 1. Theta 1 is greater than theta 2. So here oscillation 1 greater than oscillation 2. So here initially the oscillation is more and finally the oscillation is less. So here oscillation is decreasing. So this is for decreasing oscillation, this is for increasing oscillation. You don't need to memorize it, you just need to understand how to determine the changing oscillation or increasing or decreasing oscillation, just to draw two angles. If angles are increasing, that means slopes are increasing and oscillation is also increasing, and if angles are decreasing, that means slope is decreasing and oscillation is decreasing. And in third case, oscillation time graph, if the oscillation is changing, we can draw it with this manner. If at a constant rate, if oscillation varies with time and rate of oscillation, rate of oscillation is varies, then we can drive it anywhere that you need to discuss forward. But there are four cases related to the velocity which are very important, which we have discussed in this video, and we bind up our video here because length is going too long. So for next video, till the next video.